This assignment is a kind of continuation off of the previous assignment that we've done. We're going to be using the same testing and some of the same kind of methods that we have implemented. We have our database test, we have branch, we have this customer, we have our account, owns, loan, payment. These are just all tables that we're setting up here, borrows. So those are all of our tables there, and these are from the section 1, figure 1 schema part right here, and we're going off of this. Now for our section 2, we're going to want to populate our database, and we're going to do this according to section 3. Now the way we're going to populate it is the following. So this is my first population into branch, customer, customer. Note this order has to be the same order as the table was declared. So we're going to keep going down here, and I believe I actually have a table right here. So again, they're in order of this table right here. So we keep scrolling down. We can see that these are more that I implemented, some insertions. Like we have these owns right here. There's an owns right here. It has to follow this part right here, where it takes a social security number, an account number, and then an owner date. So we have all of these here, and these just are for, again, testing purposes. So we have this stops here. Keep going down. Now we're going to go from our select. So these just select and print things. We don't need to worry about that. This delete and update, we don't need to worry about it. And then we have a drops tables, which we don't need to worry about that unless we want to erase our tables. So you can just minimize that for now. And then we're going to go to our actual problem. So note how we start at problem 1 here. So we can look at our section 3. Problem 1 says to list each of the loan payments. The grammar is not very good here, but we have loan payment, payment number, amount, and method that was paid on time, and the payment was more than $15. Order the result by loan number in ascending order. The status of the payment is on time. So we know we want to get the loan number, our payment number, amount, and method. So these are obviously going to go into our select. Well, where does this come from? If we look at our tables, we can see that loan number, payment number, the amount, and the method all come from payment. So all we need in our from is the payment for now. What else do we have? It was paid on time and the payment was more than $15. So let's take the payment amount and compare it, make it sure it's greater than $15. And then let's also get the status and say that it is on time. So we have on time and status right here. Those are our wheres. What else do we have? Well, the last thing is we want to order it, right, in ascending order. So we can do loan number. So we're gonna, before we do any of this, we're gonna order it by the ascending. So basically, before any of this runs or after, whatever we get, we are just going to, by the loan number key, which is what it is right here. We have this loan number, it's the primary key. We are going to have it in the ascending order. So you just have to add this tag ascending at the end. If you get that syntax, you could probably just look it up. And now we go on to number 2. Number 2 is we list all the customers, social security number, first name and last name, who have at least a balance more than one account with a balance more than 10,000. Don't list a customer twice if he or she has more than one account satisfying the condition. So if we only need to list it once, let's have a distinct customer social security number and customer first name, last name. Now notice how I have the C right here, and that's because I did customer as C. So this customer as C should be a lowercase, just for consistency. We're getting these from this customer right here. We can also run this previous one because I didn't run it just to make sure it works, and it works. If you don't want this null here, because it's not always going to appear here, it just appears on MySQL because it's just blank. I think there's a way that we can get it so it doesn't get null values, but that's just the output for that. Now for number 2, we have our customer as C. That's going to be like this for here. And now we know that we want to check the accounts, right? Because we have this account right here. So what we need to do is we need to join our account with our customer. We can see we have customer owns account. Since this is a many-many relationship, we're going to have to go through here. We're going to do account, inner join, owns. So account and owns are going to join on their common based on the fact that their account numbers are equal to each other. So account inner join owns on the fact that account number is equal to the owns account number. And then after this, we need to inner join it with our customer on the fact that our owns customer social security number is equal to our customer social security number. And that's because owns holds, since it's a middle part, it owns the social security number and the account number. That's just how a many-to-many relationship would work. that's how we implement it here. So now that everything is linked, we can get everything. And the last thing we have to do is compare it to an account with more than a balance of 10,000. So you do account.balance is greater than 10,000. So that's going to be this. We can run it, and we can see that it's going to be all these accounts right here. If we wanted to, I'm sure we can also do account. We can do dot, and then there should be a balance. So we'll do balance, so we can actually check the balance of these accounts real quick. And then we can see that they're all this much. So I guess they all own like the same account right there. So we can remove that just for our query. Next we can go to number 3. In number 3, we want to list all customers, their social security number, first name and last name, who own more than 2 accounts. If an account is shared, we should also count it in. So we're not going to worry about this last part, just the customers that own more than 2 accounts. So we're going to have a customer social security number, customer first name, customer last name. Just like the previous one, we have to link them together. Now, we can implement this customer as C inside of our join. I could have put customer as C right here. So that's just something to note. We didn't have to do it there, and we actually implement this right here. We have customer as C inside of here. We interjoin with owns. Notice how we do the owns first this time instead of the account this time first. That's just because it's interchangeable, just on how it's written. So for this, we have our customer as C interjoined with owns as O. So we are doing an aliasing here on the account that our customer social security number is equal to our own social security number, and then we interjoin it with our account as A. So this is another alias right here on the account that the account number is equal to the social security account number, or the owns is equal to the account number. So we're just doing a join right there. And then we also want to group by the social security number. The reason why we group by the social security number is because we want to see if the account is like shared. I actually don't think that we actually need this group by social security number. Let's just do a comma right here, and then we're going to print out count, and then we'll just do an asterisk like this and see if this changes anything if we were to run it. So we can run it, we can see we have a count of 4. We can delete this, and we can rerun this. We see we have a count of 6. So I think without it, it's actually counting the things as double. So we're going to keep that in because I guess it is important so that it doesn't count multiple things that are the same, because I believe there's only like 4 inside of here. So if we rerun this, and then we are also checking to make sure this person has the count of our account number be greater than 2. So this has to be greater than 2. And that's going to be it for number 3. Next we can look at number 4. We want to list all customers who own an account, and it's this. Well, we're going to do the inner join, just like we've done previously. We are going to have distinct. We want to print out the customer social security number, customer first name, customer last name, customer phone, and we're doing this without any aliasing for this one. And this is where our account.account number is equal to this right here. So that's just important to note. We have the same kind of from as the previous ones. This needs to be distinct, and our account number is this right here. So if we run it, we are going to get these 2 people. Next we can look at number 5. We want to list each of the loan payments, so payment number, due date of John Smith that has been paid by check. So payment number, payment due date, we're going to alias payment as P. We know that we need to interjoin this, so we need to interjoin it with customer really, because the payment has to go all the way to our customer John Smith. So payment as P interjoins with our borrow, and the reason why it doesn't need to join with our loan is because the borrows is it's a many-to-many relationship, meaning it's its own thing. So we have our social security number of our customer, and we have the loan number. And this is on the account that our P loan number is equal to our borrow loan number, and then we just interjoin it with our customer as C, when the social security numbers match. And then we just check the name and the payment by check. Next we have number 6, and number 6 is saying we want to list each the customer's social security number, first name, last name, who has at least 1 loan, list the customer only once. So we're going to need to do distincts. Now we can actually run this also, make sure it works good. We can see this one works good, and we're going to look at this one next. So we list everything that we want inside of our select. Inside of our from, it's going to be from our customer. So customer SSN, right? And then we're not doing any aliasing here, just by the way. So if we want to make sure our customer has at least 1 loan, we're going to join our customer and borrows, because we can check the loan from there. Because if they're borrowing something, that means that they have a loan. So from customer, inner join with our borrows, it's going to join on the fact that the social security numbers are equal to each other. So if they join, that means the customer has a loan, and then we're just going to print this out. So that is how that would work. Next, we want to retrieve all the loans that John Smith has. If a loan is shared by him and other customers, we should count it in. Please list John's social security number and the loans he has. So we have a customer social security number, and then we're at this count star right here. In this count star, it's only a star because we just are going to count them many times since they're a join. If we wanted to, we can have count, and then we could also put like the loans or payment dot number, whatever it is, inside of the parentheses. So we know that we want to go from customer to the number of loans, but we can just do this through our borrows. So customer inner joins with our borrows on the fact that the customer social security number is equal to the borrower social security number. And this is where we have our customer first name and last name as John Smith. And then we also want to group by the customer social security number in case there's any other customers. So if we run this, it's going to just look like 1 because our John Smith only has 1 loan. Next, we look at number 8. Number 8 is to retrieve the total balance of a customer if a customer has more than 2 accounts. If the account is shared, we should also count it in. So we're going to list social security number, number of accounts, and total balance. So in our number 8, we are going to have social security number, first name, last name, and then we also want to have the total balance. So we can use our sum right here, and we're going to pass in our account balance. So it sums the total account balance per this customer. We're going to group by the customer social security number, your first name and last name. Don't think this is 100% necessary though to group by all of these. So we can just do the customer social security number. It should run the same also. So if we run it, and then let's delete these, and then we run it again, we're going to see that it's the same. So it gives us the same output no matter what, leading us to believe that we do not need those. And then we need to join this with our account. So we have our customer owns, and then basically joining with our account what we've done before. For number 9, we want to list each customer with his or her favorite branch. So we are going to list the customer social security number, first name, the customer last name, branch name, and branch address. So we actually don't need this customer first name, so we can take that out. So those are going to be all in our select right here. Next is our from. Also, if a customer does not have a favorite branch, then the branch name and branch address should be null. So instead of doing a left join, what we want to do is we want to do actually this is a left join. Should be a left outer join though. We've talked about outer joins previously. It's in the playlist link below the like button. But essentially this branch right here is going to join with all of our customers. So all of our customers are going to be listed out, and then all the branches are going to go with our customers. Now, if there is no branch, then it's just going to be null. And this is on the fact that the customer.favorite branch is equal to our branch name. So we can run this, and we can see that this works out. Now let me modify one of the test cases, or I can actually add one right here. Let's just add a new customer. Okay, so that test person failed. It was because it has to have this Bank of America in it, possibly because we just can't have anything in here. So we'll just delete this, and I'll change the name. We'll do test person a bunch of 2s, and we'll add this inside of here. I think if we just type in null like this, we can run it now. Now we have to change our customer key. So let's change it to this, and then insert it again. Okay, so now we have populated that. So just make it null, and that should work. Now going back to number 9. So going to number 9, we can press play, and we're going to see that we have a person with null values inside of here. So that is how this would work. They just have nothing, no favorite branch. For number 10, we have for each customer who has a favorite branch, list their social security number, last name, and name of their favorite branch. So this is all happening from our customer. This is from customer, and then we have this where exists. We can reformat it to look like this, select, and then we have favorite branch from customer. So this is basically seeing if there is a favorite branch from our customer, and then we have this where exists. So if this exists, we return it, and then we have our customer's favorite branch right there. Since we have multiple customers in here, we should probably denote these a little bit better. So these will be customer as C like this. I don't think it'll change much, but we should run this again. I think another better way to do this would be to join our customer and our branch, and then just print out the customer. So favorite branch, we have this right here. Customer has a favorite branch. Just joining customer and branch together. So we can do customer as C, and our branch is this first one right here. So we have the branch name and address, with the primary key being the name. So we have customer as C, and then we could just do an inner join because we don't want to print the nulls. And this is going to inner join branch on, and this is kind of like the last one, the fact that these two are going to equal each other. The customer's favorite branch name is going to equal to the branch name. So let's do that, and let's take that out. And then we can make this a C since we changed this to be C right there. We can select and run it, and we can see it only prints these out without the nulls. So that fixes some of that code right there. For our number 11, it's pretty simple. It's just saying to retrieve the highest fee among all accounts. So we're going to get the account, and then we just get the max fee from it. We want to select max fee from it. Let's see if we can just do account.max fee, and then end this line and not include this. So let's see if we run it like this. We get an error. Okay, so it looks like we do need the account right here. If we rerun it though here, we're going to get the max fee, which is 88. Lastly, we want to retrieve the loan that is the highest interest rate among all of our loans. We want to list the loan number, type, and interest rate. So we are already going to do loan number, loan type, loan interest rate in our select. This is all happening from our loan. And if there's a type highest rate, list all loans with the highest interest rate. So there's no distinct right here. Then we're going to have our where. We want to retrieve the interest rate that's highest of the loans. So we're going to do this in our where, not a join, because we want to retrieve the highest interest rate. So we want to say L.interest rate, because this is from our loans, and then we want to select the max interest rate. So basically, we're going to return the max interest rate in our where, and then we print out all this information according to it. So we're going to have this other statement inside of here. We can better space this out. We can see it's going to be like an inner query. So it's going to be something like this. We have a select, where we select our max loan interest rate from our loan, and then we're just going to send it here, and then we're going to print it out. So those are all of our examples that we have gone through. That's going to be it. We've done so many, and those are a great way to look at the different ways to do some queries.